Mm.
All right, we are live. For everyone joining just now, we'll get started in just a few minutes. Yeah, this is the introduction to qBraid.
Sweet. All right. I am ready to share my screen whenever. If
Go for it.
sweet. Hey all, super excited to be part of QC Hack again. I think you guys might have seen me here and there. My name is Ricky and I'll be guiding you guys through how to use qBraid and accessing the credits that you will use for your hackathon and accessing Amazon Brocket devices such as Rigetti's M1, which is an 80 cubic quantum computer that you will be using for some of the challenges in qBraid. And not only that, we also have the amazing opportunity for you to also code whatever you want. If you haven't installed everything for, say, IBM, and you're having trouble doing so, it's already pre-installed for you on qBraid. And this goes for the same for Q# as well and QTech mostly. You'll just need to install the squid package that they were mentioning. Otherwise, let's get started. First and foremost, I want everyone to just kind of log in first. And I think I did put the information on Slack, or sorry, on Discord, but I will drop it again. First off, go to qbraid.com. And you should see the, mine's going to get redirected, I think, to my account page. But essentially, you should click login or sign up if you haven't already done so. And you do have a Google login as well as a ability to also do regular logins. You will need to verify your account on your email as well. Once you do so, just message in the Twitch stream, and we'll proceed afterwards. So I'm going to give 10 seconds for that. If you do run into the issue where your username or something isn't showing up, unfortunately, I think our API had some issues with copying like the user info from our old one to our new one. And we'll have that up and running, but you'll just have to kind of sit and watch the tutorial as I show you to everyone. And I apologize for that. Let me get my Twitch running as well so I can debug as necessary. So yeah, once we've got that going, we will add our access keys. I have no idea. I'm just going to start adding them. I've already added mine. This will give you access to essentially the SDK that we have, as well as the Amazon Brocket, the environment, and all those like good things that make qBraid so special. So first off, just type in NYUAD22, and you will be told whether you have access to the environment manager or need to get access. This is our code from our last hackathon, which is partnered with QC Hack. And then once you've applied that, you can apply for beta credits as well. And you will get around 5,000 beta credits. You can't get any more, but if you do end up using it during your QC Hack, more than 5,000, just let us know and we can allocate more as necessary. And yes, I have my 12,000 credits here. Is everyone following? Is everyone okay? I just want to make sure before I go on. Not really sure, but I'm just going to keep chugging along. Afterwards, you can go to the home screen after you've applied your credits. Once you have done so, you can take yourself to lab, which I have done so already. So click lab, and then you will be taken to our environment where you essentially are able to code quantum computing on quantum computing devices, as well as like use the quantum computing languages a lot faster than if you were to traditionally do this on, say, VS Code or any other IDE. In the meantime, while it's loading, I just want to show that you have blogs, papers, and news available as well. So you can essentially get the latest in terms of the papers, for example, that are written and posted on Scirate. And we essentially provide it in one easy way for you, as well as blogs that are written by our users. We're going to be updating that very, very soon to make it a lot more smoother of an interface. So stay tuned. Some super exciting stuff. So yeah, this is just like an example of a paper. And I think lab has loaded for me. And it does take a little while. We do import a lot of things and get your environment set up correctly. And that does take a minute, but please be patient. It shouldn't take more than, I think, 2 minutes for this to load. And then you should have, yeah. So once you are in, you should have access to a bunch of tutorials. I was actually just looking at the European call option tutorials from Qiskit, but once everything is loaded in, I will kind of walk you through some of the functionalities that are available to you. And in the meantime, I'm going to pull up NYUAD. This is the old, we've made this repository public because this hackathon has already passed, but essentially I will make sure to git clone this and show you the git clone functionality, as well as a few other functionalities that are needed for you to be successful in this hackathon. So without further ado, let's first start off. I have a bunch of notebooks here, but you are able to essentially, once you log in, the first thing you should see is the qBraid tutorials notebook. In here, you'll find essentially a ton of awesome resources. We have tutorials from AWS, Google, IBM, Microsoft, Project Q, as well as Quantum Inspire, and so many more, as well as our very own. We will be going through the AWS tutorial today, but before that, I need to essentially show you guys a few things about enabling your account. So on qBraid, you don't have to essentially set up a lot of the, say, Amazon S3 environments and or S3 storage, as well as all these like kind of cloud resources that may be foreign if you have never done any DevOps, or if you've never done any software engineering. We like to make sure that our users can focus on the quantum and can do great work in the quantum space quickly. And so what we've done is we've kind of optimized that, and I'm going to show you how that works. And then after we kind of run through that circuit stuff, I will then show essentially how to clone the hackathon repository into your qBraid lab, and then you'll then find yourself to have a really easy time just kind of like working on the hackathon and kind of working with your team using Git. So without further ado, I'm going to make sure that my account is enabled for AWS. Actually, first, I'm going to make sure that I have qBraid's Broadcat environment installed. So right here, you're going to find that what you're going to need to do, I'm going to uninstall and install it. And we'll go through this whole process just to make sure that everyone is successful in using Broadcat. But so yeah. Fresh. We're going to run through and make sure that we use Broadcat first and install it. Then go through the process of enabling your AWS account, and then run the AWS example circuit to run on various backends. and then we'll be good to go. Is there any questions? Any questions? Probably not.
Yeah, we had one person ask, do they have to add themselves to the qBraid channel on Discord?
It would probably be strongly recommended, since if you do work on like the qBraid challenge, or if you have any questions about qBraid, we'll be able to respond to you quickly.
I think they're more asking like if it's a private channel, they need like to request access.
Yes, to gain access, you just have to pick the qBraid challenge in the roles section. And in the roles section, you should be able to essentially, once you click the qBraid challenge, you gain access to the channel. Okay, I don't know why my lab is not running, so I'm going to reload it and then just double check. All right, seems like it's just hanging for a bit. Yes, so quantum queues, if you have been prompted to upgrade to install Bracket, make sure that beforehand you have passed in the code NYUAD22, because that in the account page, and I can kind of walk through that right now. So here, go to your account, and you should find that clicking on account will take you to the account page where you add an access key, where you should have the access key added here. And just click add, and then you'll have access to the lab environment manager. If you don't, if you just made your account, there might be a chance that we need to fix your account, because our API hasn't moved some of the users that are just added to its database. If that's the case, we apologize. That might be something that you encounter. Let me know if you have any issues, quantum queues. We will be happy to kind of debug with you. All right, so hopefully Jupyter Lab is back. Just gonna wait for it. And it should work. I'm going to install Amazon Bucket then. After. And if while you add your NYUAD22 code to the access keys on account.qbraid.com/account, if you also don't have credits, we feel free to add 5,000 credits by just clicking beta credits 5 times. Usually doesn't take too long. We just have a lot of users. Not entirely sure. Refresh again. I don't think my computer likes when Zoom is running, to be honest. Sweet, quantum queues is good to go. Great to hear. All right. Mm. Oh yeah, I think I'm using slow internet at home, so that might be the issue. We'll just wait. And then if it takes too long, Ryan, I think we can just kind of share screens and switch over. Is that okay with you?
Yeah, it works for me. I can share my screen, right? We can just switch to mine right now if we need
Yeah,
to
that's fine.
until yours works. Sounds good. Okay, share screen and just let me know where I should be going.
So just install AWS Bracket, then run the CLI command, and then we should be good.
Cool. All right. Are we seeing my screen now?
Yes.
Cool. Okay. In that case. All right. So I have AWS Bracket installed. Activating it will populate a Jupyter kernel that I can use to automatically have access to Amazon Bracket. As Ricky was saying, using the qBraid jobs, you want to pass the qBraid enable account AWS Bracket, and you're now submitting jobs with qBraid jobs. This keyword can be found if you just run qBraid ems. You can see a list of the environments that you've installed, which should align with what you see over here in the environment manager. Once you have the AWS Bracket account enabled, then opening up a notebook, I already have this code loaded. Make sure that you're using the correct kernel for Bracket. Once you have that, then you can import and then start using and submitting Amazon Bracket. And then at any point, you can do qBraid disable account with the same command, and that will take you back to using your own credentials. What's next, Ricky?
Yeah, so I guess we can wait a little bit to make sure that everyone can use those. And then in NY, so can you remove the NYU AD 2022? I'm gonna give you the link so then people can get cloned.
Oh, can I remove it? Yep.
Yeah. You might want to rimwrap because there are things inside. So what Ryan is doing is he's using the terminal to delete it, given that Jupyter, we use a Jupyter environment, and the lab environment makes sure that you don't delete a folder if there's stuff inside it, and it takes a while. So what we want to do is just git clone NYUAD. You'll do a similar thing. Once the repository is made public tomorrow, you will just git clone the QC hack environment. And then inside you'll find tutorials for Amazon Bracket, as well as for qBraid, just in case you didn't follow through, and then you will be able to work on qBraid. So let's grab the link, and then you can clone a repository. You can also, if you're familiar with like git commands and git CLI, then you should be able to use the git cloning functionality in a terminal as well. So once you are in, you can click NYUAD-22, Amazon Bracket examples, and then do getting started.
I'm getting started.
And then running, it's the second running one. So 2_running quantum circuits.
Okay. I'm gonna do disable
Sure.
broadcast just so I can be a little bit faster this way since I have remove my big okay, now I should be good. Broadcast.
Most people won't have to do that. It just,
No, yeah, most people won't have to do that, but I'm just running a little fast. We want to make sure we're running fast, not lagging. Okay. Yeah, so yeah, so this will be the process that you'll use to over here on the sidebar, using the git integration to clone over that repository. If you're familiar with the command line, like Ricky said, you can also use git clone command from the command line. That'll also work. And then you can, and what we have here is really, this is just a user interface for the file system that exists already in your lab home directory. So if I was to do an ls of my home directory, that's going to be consistent with what we see over here. All right, what's next? Just run these.
Yep, just run the, and you might have seen this before. Yeah, so scroll up.
Oh yeah, I got my it's yeah. The request is valid. Yeah, I gotta refresh mine too. It's the JWT token.
So if you get like a token issue, that just means that we need to refresh your account token, and you just need to refresh your lab browser tab. You may have seen this tutorial before if you attended the Amazon broadcast tutorial, and where they used an event engine where that kind of helped with the login process. Essentially, the login process for us is through qBraid. This is a real account. You can use this as much as you want, and then
it's actually my AWS credential. Anyways,
yeah.
Yep. Ricky, I'm going to stop my share for a second because I think it's actually my AWS credential that's incorrect. So I don't want to like broadcast that on the screen. So I'm going to like look at it really.
Sounds good.
Stop my share for a quick second.
Yeah. In the meantime, I can kind of troubleshoot if anyone has having. Yeah. So, Ann Hawkins, great point. I think what has happened is we are not saving new users at the moment. That is an error on our side. I'm not entirely sure why this is occurring, but we are running a script that will update everyone at the moment. So hopefully that will kind of clear up that issue where the user is not found is no longer the case.
All right, perfect. I'm back. See, that was it. That was all it was. Yeah. Cool. Okay, we're back. Yes, now I'm execute this whole notebook. And all right. What's next? What are we doing next, Rick?
Yep. So once you've run your jobs, if you've gotten to this point, you can essentially check that you can run your quantum computers, your circuits on various quantum computers provided by AWS, including Oxford Quantum Circuits Lucy. Clearly, it's completed, which is very, very nice. And then afterwards, if you're interested in like how many credits you have left, because we do take a certain amount of credits every time, you can just run qBraid credits. And that will essentially return how many credits you have left. And Ryan has 903 qBraid credits. If you haven't been able to kind of figure out how to navigate qBraid so far because of, say, a login issue, or say your credentials weren't added in properly, that's on us, and we'll make sure that that's fixed as soon as possible, probably within like the next hour. And then we'll try and troubleshoot for anyone who did have that issue. But now I think it's time, 6:30 almost, and I think, Ryan, if you can do a demo on the SDK and how amazing it is, it's really cool. It's something that is quite truly really exciting, because I'm sure you've had moments where you want to try and run your Qiskit circuit on maybe like one of the AWS provided backends, and this is kind of a pain point that we felt as developers as well, who are familiar with quantum computing. So Ryan did a really spectacular job in getting it a super cool SDK to transpile things and run things on different backends.
Cool. So can actually follow along. If you were successfully able to get into qBraid, then here is a link to the demo. Let me drop it in the drop that in the chat. Okay, so if you want to, you can go check that out, and that has all the cells kind of executed, and you can see what I'll be doing. I'm going to be, whoops. Cool. So I'm going to be demoing the qBraid SDK now. So what I'm going to do is go qBraid lab demo, which I already have cloned over. I'm going to come over here to qBraid, make sure I have the SDK environment active, which I already do. And I will start with the transpiler. Start with the qBraid Sdk Transpiler. Okay, so the motivation behind the SDK was to be kind of a quantum developers, a tool that they would be able to use that would make the development experience a little more smooth. Kind of use it as, as someone who both studied, quantum in college, and I did research in quantum, and now I'm kind of working in industry. I've dabbled in open source as well. There's a lot of things that I started to notice that, I was saying to myself, I wish there was, a software package that would enable me to do this or that. So after I joined qBraid a little over a year ago, I've been working closely with a few of our other developers at the company to kind of put that into action. So what the qBraid SDK is it's a it's a front-end software package that's used to interface between many different supported software packages. So from Qiskit to Brocket to Pennylane, PyQuil, and Circ, the SDK is kind of an interface that will allow you to access the functionality of each of these front-end modules, and kind of do it from one point of contact rather than diving into the syntax of each module separately. So so as you can see, the SDK supported program types. We have Circ circuits, PyQuil programs, Qiskit quantum circuits, Brocket circuits, and Pennylane. So starting off with the transpiler with just a very simple Bell circuit example. So what I have here is just This is just a testing module that we have, which this will just contain a bunch of like the Bell circuit implementation in each of these front end packages. So what I'm going to do is I'm going to pick 2 of these packages at random out of the supported programs list. And I'm going to kind of just demonstrate how you can transpile Bell circuits from one package to the other using the SDK. So let's say we picked PyQuil and we want to go to Broquette. So we're first going to instantiate the circuit object in the source package. So this is the PyQuil program Bell circuit. And now the next step would just be to apply the qBraid circuit wrapper. So right here from the top, I had from qBraid import circuit wrapper. So now I'll do circuit wrapper of the source Bell and print that program type. So as you can see, we have a qBraid transpiler of a PyQuil program wrapper object now. And then all you have to do from here is then wrap circuit.transpile to the target package, which was declared as Broquette. And then after you do that, now we have the Broquette circuit. It's that easy, circuit wrapper.transpile. This is, a tool that I kind of wish that I had when, for instance, you have a quantum program or you have a script written that was implemented in a certain language very cleanly, very well, instead of, copying it over to a different package that might have access to a backend that you need to access, or that has a different utility function that first package didn't have. The transpiler is kind of here for you. So we could run them all again, pinning lane to circ this time, and show that that's working just fine. Okay, so we'll go to a more complex example now. Let's make a Qiskit circuit that's a little bit larger, 4 qubits, 15 unique gates, and apply the circuit wrapper there. As you can see, our Broquette circuit now just maps each of those gates pretty cleanly over. And then the same thing for circ. Now we have the equivalent circ circuit. One thing that you'll notice is, the circ circuit kind of appears flipped in comparison to the Qiskit circuit and the Broquette circuit. But this is really just because of the indexing between the packages. So what we care about is not, whether the circuit diagram is mirrored or not. We care about whether the unitaries are equivalent, right? So another little module that we have, circuits.allClose. So circuits.allClose, we'll start with 2 unitary. So 2 unitary is a qBraid.interface function that you just pass a circuit in any of these supported front ends and it'll spit back the unitary. So, instead of Broquette.circuits. Calculate unitary dot to unitary or circ dot, each module has like their own version of it. And for me, it was hard to keep track of all of them in my head as a developer. So the 2 unitary is kind of your interfacing unitary function, and circuits.allClose is a pretty helpful testing module where you can pass 2 circuits of any of these program types, and it will tell you if those circuits are, if their matrix representations are equivalent. You can do so and kind of control your level of tolerance, kind of like NumPy.allClose. And what you can also do, and I'll get to this a little later, is dictate whether you want, like how you want to index those circuits in comparing their equivalence in terms of the qubits. So that's a diversion, but getting back to what we're doing. Okay, so now we'll run circuits.allClose of the Qiskit circuit, Broquette circuit, and compare the other ones, and they look like they all check out. Okay, moving on now, we'll stress test the transpiler a little bit and show you what it's kind of capable of. Because I'm always a skeptic, of any type of software that I see, all of my comparison functions that we see could be, we could be doing some pre-processing behind the scenes and making these circuits equivalent or whatever else. So this time I'll just use some random circuit generation through circ. to show you that these truly are randomly generated circuits. These are large circuits, right? So for example, one popular use case is, Qiskit has a bunch of modules for like financial programs, like whatever other programs that are really robust, really well built out. But if you want to execute these programs on actual quantum computers, Qiskit, IBM Q limits you to 5 qubits, right? But in Brocket, through their modules or, through other vendors, they have QPUs available to their users that are more than 5 qubits that allow you to, execute these programs that are built from more than just 4 or 5 qubits. So using the transpiler, you can easily take a Qiskit program and execute it on like a Rigetti backend, or or some other type of backend via the qBraid transpiler. So here we have a 8 qubit circuit. So it's pretty large, and what I'll basically show here is taking that circuit from Circ to Barquette to Pikeville to Qiskit to Penny Lane back to Circ, and then compare them and their equivalent. And that's kind of what the qBraid transpiler can offer you, is just a helpful way to interface between a lot of these front ends. Okay, so the qBraid transpiler was kind of only the beginning of where we wanted to take the qBraid SDK, because the purpose really wasn't just to interface between circuit modules. Is we want to actually make it easier for people to execute those circuits. Let's say that you are like a Qiskit developer and you want to execute it on an AWS device, but you don't necessarily, you're not well read on the documentation that they have about how to work through AWS and S3 and like provisioning resources and like where do I store my results and how do I get them back? What format are they going to get back? Right? You're a Qiskit developer. It's not something that you've well read on, and that's kind of one example of how we wanted to make the qBraid SDK useful. So what we have here is from qBraid, you can import Git devices, and here you'll get a list of all the quantum backends that are supported by the SDK up to this point that you can execute your circuits on. So as you can see, they're kind of sorted by the provider. You get the name of the quantum backend, and then you'll get a device ID, and then here you'll get kind of like a status bar. So when you instantiate a quantum device and you do like device.status, and it'll see whether it's online or offline. We've compiled all of that right here for you, and you can see kind of in real time, which devices are available to you. Not only that, but so as you can see here, like the device statuses are updated pretty regularly. If you want to get it current, just throw refresh as true, and it'll take about a minute, and then it'll refresh all the device statuses. As we continue to build out the SDK, we continue to add more devices. So what'll be super useful, and what is already useful, is filters that you can add. So let's say that you want to search for simulators that have the state keyword in them across AWS and IBM. We can, so as you can see, refresh devices. Now, all these are current up to the minute. And then here in this get devices query, right, we have all the devices that have state keyword across AWS and IBM. And these are the ones that are available to us. So similarly, like we can search by number of qubits, we can search by status, we can search by, the paradigm, so gate-based, annealing, all these options are available to you. The qBraid SDK docs will be released soon, but you can always throw help get devices and see some examples of queries that you can do, and also reference this query selectors docs for help on syntax. Okay. So once again, search by whether a credential is required. So whether you have to have an IBM Q or an AWS credential or not. Okay, so now we're going to move into the device wrapper. So before we saw the circuit wrapper for wrapping quantum circuits and passing them back and forth between packages. Now we have the device wrapper. So this is our way of kind of giving you access to the information about these quantum devices and their capabilities, as well as executing on these devices in kind of a unified format. So let's say we wanted to apply the device wrapper to the IBM Air CASM simulator by saying device.info. We automatically have all this information about it. You know, it's very helpful for, let's see, we can do if we want to do, say, true for that, we'll go like IBM Q Santiago. And now, you know, now we're doing the exact same and getting information about the number of qubits that it has, you know. Okay, IBM Air as I think that's what we're starting with. I think that's, yeah, okay, cool. In addition, okay, so IBM Q least busy QPU from the qBraid API. You can import this and see, you know, all different QPUs have queues that you have to wait in, you know, for availability. So after you submit your quantum job, right, it could be 10 minutes, it could be an hour that you're waiting for it to finish. If you want to go to IBM and look up the least busy one, just run the least busy QPU. It's IBM Q Armonk, no surprise, because it's only, I think, a 1 qubit device. So maybe not many people are wrapping it. Yeah, right. But that's a little tidbit. All right, so let's get to executing a quantum circuit. So from Qiskit, import quantum circuit, make a random one. And then after we have this device wrapper, right, we have the qBraid device, device wrapper. It's of type print type device wrapper or qBraid IBM Q device. This kind of helps me too. So Qiskit backend wrapper, right? We have the qBraid devices Qiskit backend wrapper, and each backend wrapper or, you know, device wrapper has its own .run method. So these .run methods are, you know, for Qiskit, this would be like your .execute function. For Broadcat, this would be a .run. I think for circ, it'd be like .sample, or for simulators. And then I think it'd also be a .run for circuits. But you know, when you're thinking about executing on a quantum backend and you're not familiar with that package because you're coming from a different, you know, circuit building front end, you know, we've kind of taken out that barrier to entry of like kind of the syntactical, you know, hoops that you're jumping through, looking up like the keyword arguments that you're not used to. So we've kind of like unified these with these .run methods. You know, shots is shots in other, you know, programs. Shots means something else, and we kind of bring it all together. So we can run that IBM Q job and then check its status. It's a simulator, so it's already completed. And then we can just show an example of wrapping some other devices. So a Google simulator, an AWS density matrix simulator, you know, using the same .run method. So device.run for both these. And then getting the results back is as easy as, after you get the job, going job.result. Again, together. So every qBraid job has its own job ID, right? So what you can actually do is if you were to, for example, submit a quantum job to a QPU that was supposed to take a very long amount of time, like let's say you're going to run on IMQ QPU, which can sometimes take up to up to a day to run, or 12 hours or 15 hours or whatever it is. So you submit that job, you close your laptop, you exit out all of your programs, and then you open it back up, right? Depending on the the front end package that you're operating in, you can go to the the IBM Q console or to the Brocket AWS console and check on the status of the job. But what happens if I actually want to recreate that job object that I got back the first time I submitted it after the .run, and manipulate it and play around with the results with through a Python interface instead of like a .json that I get back from the so when you submit a job through qBraid, we track that job. We keep track of that job's unique ID. We pass our unique job ID back to you, which you can then use to instantiate a job wrapper object and get that job back. So all you do is pass this to the retrieve job method, and then you can go and play around with that job object as you will. Okay, so we're getting the qBraid IBM Q result back. And now what we've done, just to briefly summarize, is we've used the qBraid device wrapper to wrap an IBM Q device, a Google device, and an AWS device. We've created a single Qiskit circuit. So this is a single Qiskit circuit that we have now executed on an IBM Q device, a Google device, and an AWS device, all through a consistent .run interface. Got the results back with a consistent method, and now we're about to look at the results for running our Qiskit circuit on all three of these platforms. So these are the measurement counts that resulted from the run. And now we can just plot each of these results individually and look and see that they're pretty consistent across the three, across the IBM, or this is the Google density matrix simulator, the AWS density matrix, and the IBM Q RML. Yeah, so this is more on the qBraid Transpiler. When we're developing the Transpiler, really what we're doing is we're just kind of keeping our ear to the ground, and listening to kind of the grievances of quantum software developers, and kind of as we're getting that feedback and paying attention to the open source trends and things like this, we're developing functions and utility modules and testing modules on the fly that are just trying to basically aid your experience. So not only are we trying to be a hub to transpiling between front ends and executing on a variety of quantum devices, but we're also just trying to be an overall developer tool. So for instance, you might create a Brocket circuit and convert. Oh, I already did that. Yeah. And realized you get an error in the middle of it. Non-contiguous qubit indices applied. Qubit indices in a circuit must be contiguous. So this is one of the parameters that one of the requirements for Brocket. But let's say you had a big circuit and you don't want to go back and write the whole thing. you just use the qBraid convert to contiguous function, right? And now you just run it again, and now it works for you, right? So, this is just like one example of some of the functionality that we're trying to provide, in addition to modules like for testing, for instance, from interface. Let's say you're like running unit tests for some type of algorithm that you're developing. Import random circuit. Let's just say if it equals random circuit, and like pick a package like a Qiskit random circuit. Pretty small one. Yeah, we can control the number of qubits. Equals 4. Depth equals 5. We can generate random circuits in Qiskit, generate randoms in Circ, Penny Lane. Like, it's just a really useful tool for writing unit tests. Let's say you do that one, and then you want to make another circuit 1 equals random circuit in, I don't know, like Rocket. Let's go from qBraid import or qBraid interface import circuits all close, right? Do circuits all close, and these won't be equal, but just as an example, this is like I'm writing unit tests here in like a matter of seconds to test between modules, and that one's false, but I could do qBraid import circuit wrapper, and then 0 circuit wrapper circuit 1 dot transpile to what's a PyQuil. I haven't used that one yet. And then let's just try that one now. And then that's true. So, we're just trying to basically make your experience better. As you can see, the qBraid SDK is basically just a toolkit, developer's toolkit for interfacing, executing, building, and manipulating quantum circuits, looking at quantum devices, all these types of things. In terms of benchmarking, like let's say you are deciding on a quantum backend that you want to use for like a big algorithmic run, it's like a very large circuit, let's say, and it's going to be costly, let's say like $50 to $100 potentially to run this algorithm. And you are deciding between like an IBM Q quantum device versus a different one, like which one is going to perform better for like this specific type of program. Well, you don't have to rewrite your program. You write your program one time, right? You can send a small version of it, right? A sampled version of it to both backends simultaneously and get the results back in like a unified format. So you can compare them easily, right? It's not, all these, like each different backend and each different service will return the results of a run or give you data back in a slightly different way that may be, unintuitive to compare just at surface value. But we have this like post-processing, like we have these modules built into the functionality of like the result wrapper objects in the qBraid SDK. So it's all available to you. And yeah, that wraps up my demo of the qBraid SDK. So actually, when we just built this out today, so in addition to your qBraid enable account, Amazon Brocket. So Brocket. So we were talking about that, of how you can run quantum jobs through Brocket for this hackathon, which the qBraid challenge will be using Brocket, so you'll be able to leverage that. But we also now have quantum jobs enabled in the SDK as well. So you can go qBraid SDK, and now you can run quantum jobs through the qBraid SDK as well in Brocket. So so no credentials required, and you can submit them and interface with these other packages. So yeah, that is my demo. Any questions? Let's see them. It's like Inception. Let's see. No, we look good.
All right. Well, thank you so much, Ryan. Ricky, is there anything else you want to add before we wrap up?
Not at all. I hope people watch a little bit more and, you know, ask us questions about the SDK. Like, this is a pretty cool tool, and definitely take on our challenges. There will be written in Amazon Brocket, but again, I'd like to stress that, you know, you can, if you want to do the IBM challenge, but say you're using Python, I don't know, 3.6 or something, and it's not working locally, like, we have it set up for you. If you have Python 3.10 and you are trying to install the Qtech package, like, it'll work on qBraid because we're running on 3.9 as well. So all of these things are really amazing tools that we'd love for people to use and give us some feedback, and then, you know, enjoy the hackathon.
Yeah.
All right.
If you're curious about documentation for the SDK, it's not online yet, but if you're interested in using it for the hackathon, you can reach out to me or Ricky separately, and we can send you an exclusive version. You can get the exclusive access to the SDK docs. Yeah, so
It's exciting. Don't miss that. All right. Ricky, Ryan, thank you so much for taking the time to lead this great session today. If anyone has any lingering questions, don't hesitate to post them in the qBraid channel on the Quantum Coalition Discord. The recording will be made available later on Twitch if you want to go back and review anything. And then thank you everyone for participating in QC Hack 2022's bootcamp. This is our last event before our pre-hackathon address, 9 a.m. Eastern tomorrow morning. So I hope to see you all Saturday tomorrow for the hackathon, and have a great day.